Okay, so yesterday I asked you a question. I asked you, would you rather have 9/15 times 4, or would you rather have 7/15 times 6 of my chocolate? So let's just go through the answers really quickly because I didn't give you the answer yesterday. 9/15 times 4 is equivalent to 36/15, which is the same as 2 whole and 6/15. Now 7/15 times 6 is 42/15, which is equivalent to 2 and 12/15. So by looking at my mixed numbers, I can see that 2 and 12/15 is larger than 2 and 6/15. So your answer. This is today's maths task. I am going to be asking you, what would you rather have? So I want you to imagine you're in a cake shop or you're in a pizza shop and they ask you, would you rather have 4/8 of that cake or that pizza, or would you prefer to have 7/8? Now, we've done something like this before in school. We have used our comparative symbols to show if we think an answer is larger, the same, or smaller than another amount. But today we are going to apply that to what we have been studying this week, which is multiplying fractions by integers. So in today's lesson, when I ask you, what would you rather have, you are looking for the answer that gives you the greatest amount. So I want you to imagine something that you love eating or love collecting or love having, and that is what I want you to think about. I want you to think about what amount is going to give you the most of that thing. And this is the vocabulary we're going to try and use today. We're going to use greater than, less than, and equal to, which relate to our symbols up here. Equivalent, we are going to be converting some fractions from improper fractions to mixed numbers and vice versa. So we're going to be looking for equivalent fractions. We want to use the words denominator and numerator. Mixed numbers we're going to look at today. And you will hear me say the word integer, which, just to remind you, means whole numbers. Okay, so I want you to try and see if you can use all of these key vocabulary in today's lesson. Okay, so let's start off really simple. We have two fractions, 4/8 and 7/8, and we are going to discuss which is the greatest. Now, in this example, it's slightly easier because our denominator is the same. They're both showing eighths, but just different amounts of eighths. So we're looking at the numerators, which is greater, 7 or 4. We know that 7 is more than 4. So in this example, 7/8 is larger than 4/8. But what I really want you to do today is then expand on your answer, explain how you've reached that conclusion, and see if you can use your reasoning skills and your vocabulary to be fantastic mathematicians at home today. For example, you could say, I know that 7/8 is greater than 4/8 because. And now I want you to use your reasoning. So you could say, for example, 4/8 is equivalent to 1/2. However, 7/8 is almost 1 whole. So I know a number that gives me almost a whole is much larger than 1/2. Okay, so now we're going to apply this knowledge that we have done before to our learning objective for this week, which is multiplying fractions by integers. So what I'm going to ask you to do today, just like I did at the end of yesterday's lesson, where I asked you, how much of my chocolate would you rather have? That was kind of like a bit of a warm-up for today's lesson. Okay, so this is the question we are going to start off with. Our first question is 2/5 times 4 smaller than, equal to, or bigger than 3/5 times 3? So I want you to imagine you're back in that chocolate shop or you're back in that pizza shop and you are being asked, how much would you rather have? Which one is the largest amount? So we are going to do what we have been doing all this week, and we're going to multiply fractions by integers. But this time we are going to compare two different amounts by using our comparative symbols. Okay, so let's do the first one together. If you want to do this with me at home, please do. You can pause the video, or you can do this with me, or you can try and race me. Okay, so let's start with 2/5 times 4. 2/5 times 4, so I'm going to keep my denominator the same, and I'm going to times my numerator by my integer, 2 times 4 is 8. So 2/5 times 4 is 8/5. Now to make this easier today, I am going to suggest you convert all of your improper fractions into mixed numbers. And I think that will make it a lot easier to compare. So I'm going to do that now. 8/5 is equivalent to 1 3/5 when written as a mixed number. Okay, let's try and do the next question. 3/5 times 3. We're going to stay with our fifths. 3 times 3 is 9. Ooh, so if I convert that into a mixed number, I would get one whole pizza, one whole chocolate bar, one whole pie, if you are someone who likes pies, and I have 4/5 remaining. So I can see, both from looking at the improper fraction in this case, and looking at the mixed numbers, that this answer is larger, it's greater. So that's how I would show my answer. And then to extend that fully, you could write down this sentence, or say a sentence such as, I know that 3/5 times 3 is larger than 2/5 times 4 because when I converted my answers into mixed numbers, I was able to see that this was 1/5 greater than this answer here. Okay, well done if you got that one right and you're following me. I'm going to do another example so you can now choose whether to try and do your work independently, or if you want to carry on and watch the video for another example. This is our next question. So write this down, copy this down onto some paper and see if you can have a go at working this out with me or before me. Our next question is 7/10 times 3. Is this bigger, smaller, or the same as 5/20 times 4? Now I want you to stop for a second before you start working this out and see if you can use your reasoning skills to predict which you think is the greatest amount. So I think I can do that by looking at both calculations. 5/20 times 4. In your head, I think you can try and do that now. It's Thursday, see if you can have a go at doing this. We're on day 3. 5 times 4, what is this answer going to be? And do we think it's going to be more or less than this one? So now you've had a little bit of a time to predict. Let's have a go at answering both our questions. We have 7/10 times 3, which is 21/10. And I'm going to convert that into a mixed number, which is 2 whole and 1/10. Okay, now let's do the second calculation. 5 times 4 is 20, so we have 20/20, which is 1 whole. So this is quite a lot greater than this one, isn't it? So this time I'm going to use this symbol here. Okay, so our reasoning, our example, our proof that we understand and we can explain our answer could read something like this. I know that 5/20 times 4 is less than 7/10 times 3 because 7/10 times 3 is greater than 1. Or you could answer something like, I know that 7/10 times 3 is greater than 5/20 times 4 because this equates to more than 2, whereas 5/20 times 4 equals 1. So see if you can have a practice at either saying that out loud, writing it down, and that will prove and that will help you to remember how to also explain your answers. Okay, so I've done 2 examples now. Of course, you can still continue to watch or you can go and have a go at your work. I think I'm going to do one more just in case it is helpful, and I'm going to make it a little bit trickier this time. So stay tuned if you'd like a little bit of a challenge. Right, our last and final question is 6/9 times 4 and 5/9 times 5. What would you rather have? So, don't forget, you can draw this out if it makes it clearer to see. I have drawn 4 rectangles here and divided them all into ninths and shaded in 6 of those 9 ninths. So you could count how many ninths that is. we can do 6, 12, 18, 24. So this is 24 ninths, and here we have 5 ninths multiplied by 5, 5, 10, 15, 20, 25 ninths. Now, do we need to convert them into mixed numbers this time? No, we don't have to. We can see by looking at both these improper fractions that the denominator is the same. So for this example, we don't have to convert them into mixed numbers, but it's always good practice to do that. So I'll quickly do it because it's always good to just practice as many math skills as you can. 24 ninths equals 2 whole and 6 ninths, and 25th ninths equals 2 whole and 7 ninths. And again, don't forget to use your reasoning skills to prove how you know that this one is larger than this one. Okay, this is your learning for today. Would you rather? So you can take a screenshot of this to remind you that you are using this vocabulary today. You could take a screenshot of this to remind you that you can draw your fractions out. It's up to you. You can, of course, rewind the video, and I hope that you are able to do this math learning today. You're doing really, really well this week. Keep it up, and I will see you tomorrow. Bye.